Hey there guys. Hope everyone's well. We're jumping into O-level chemistry lesson 4, the periodic table and trends. The periodic table arranges elements by increasing proton number. Periods are horizontal rows, groups are vertical columns with similar valence electron counts and chemical properties. Protons set the element's identity, neutrons change mass without changing which element it is, electrons occupy the space outside and drive bonding. Group 1 metals, Li to Fr, have one outer electron and form +1 ions. Reactivity increases down the group as outer electron is more easily lost. Group 7 halogens have 7 outer electrons and form -1 ions. Reactivity decreases down the group. Across period 3, elements change from metal, Na, milligram, Ul, through metallord, Psi, to non-metal, P, S, Cl, R. Metallic character decreases left to right as atoms hold electrons more tightly. Oxides change from basic, Na2O, through amphoteric, Al2O3, to acidic, SO3, P4O10. Chlorides of Na and milligram are ionic and dissolve AlCl3 and SiCl4 hydrolyze, PCl5 and SCl2 react with water. Ask whether electrons are transferred or shared. Transfer points to ionic, sharing points to covalent. That single question organizes most of bonding. Atomic radius decreases across a period due to increasing nuclear charge pulling electrons closer. It increases down a group as shells are added. Shells are energy levels around the nucleus. Chemistry happens mainly with the outermost electrons, the valence shell, not the ones buried inside. Melting points of group 1 metals decrease down the group. Halogens show increasing melting point down group 7 as van der Waals forces between molecules strengthen. Ask whether electrons are transferred or shared. Transfer points to ionic, sharing points to covalent. That single question organizes most of bonding. Transition elements, D- block, form ions with variable oxidation states, colored compounds, and act as catalysts. Iron in hemo-GLOH-bin and nickel in hydrogenation are examples. Their properties differ from main group trends because d electrons are involved in bonding. Ask whether electrons are transferred or shared. Transfer points to ionic, sharing points to covalent. That single question organizes most of bonding. Group 0 noble gases have full outer shells, helium-2, others 8. They exist as monatomic gases with low boiling points that increase with atomic size. Atoms bond to finish an outer shell, usually 8 electrons, or 2 for the smallest. Stability, not wanting friends, is the driver. They were once called inert, but xenon compounds are known. Unreactive behavior still follows from stable electron arrangements. Displacement reactions show relative reactivity. Chlorine displaces bromine from bromide solution because Cl is more reactive. Trends must be explained with electron structure, not memorized alone. Link group number to ion charge for main group elements. Group 2 forms 2+, group 6 nonmetals often 2 in simple ions. Diagonal relationships between period 2 and period 3 elements occasionally produce similar properties. Lithium resembles magnesium in some reactions, and beryllium resembles aluminium. Recognizing these exceptions prevents oversimplified predictions when comparing elements that are not in the same group or period. Group 4 shows a clear trend from giant covalent carbon, diamond, graphite, through nonmetallic silicon to metallic tin and lead. Count the shared pairs between the atoms. 1 pair is a single bond, 2 a double, 3 a triple. More shared pairs usually means a stronger, shorter link. Predicting whether an oxide is acidic or basic from element position saves time in structured questions about period 3 and beyond. State period and group, give outer electron count, then predict ion formed and trend in reactivity or property with one-sentence explanation. Potassium is more reactive than sodium because its outer electron is farther from the nucleus and lost more easily despite similar shielding. Protons set the element's identity, neutrons change mass without changing which element it is, electrons occupy the space outside and drive bonding. Do not say reactivity increases down group 7, or confuse period with group. Practice. Why do noble gases rarely react? Answer: they have full outer electron shells, so gaining or losing electrons is energetically unfavorable. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. Chlorine water is added to potassium iodide solution. What is observed? Answer: brown iodine forms. Chlorine displaces iodine because Cl is more reactive. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Alright, that wraps up the periodic table and trends. Next time in O-level chemistry, we'll get into ionic bonding and giant structures. Stay curious and see you in the next lesson.